this. I'll put the pen, use this pen. Anybody have a preference in color? You see a pretty color or something? Purple?
Blue. Purple. Blue. Green. Blue.
Right now.
How about we do orange for the Blazers? All right, Shane, number 12. Make sure, please, that you're following along. We do have a test over this next week. Whole purpose of doing this, not because I'm too lazy to walk around the room and just check you off for your homework, but to try to make sure everybody's understanding. So looking at your book, making sure whatever somebody else writes up there makes sense.
Yes.
No, too, if you spell it wrong, I'm counting it wrong. You don't buy that, right? You know better than that, come on. I don't count spelling. Not an English teacher. Number 13, Jesse.
Let me take that.
Message, yes.
How do you change your slide? You change your slide?
No, all you gotta do is click, use the pen to click it. Well, no, you might have to, yeah, I better explain that because it's gonna, with it being on pen. What you'll have to do when you come up to get your number to come up, push the concave button. What's concave mean? The one that's going in, push it, that'll pop up, you hit next, and your number will pop up. When we get through, when we get to a good stopping point, I'll stop it, I'll stop you guys, and I'll go up and actually check them. We'll go through them all. Number 14, Michael. All to help you out, Michael.
Second.
Concave button. Next. To help you out, in case you're having trouble, I mean, maybe you're not. If you draw number 14, would it make it a little easier to do? Yeah, probably. But that's up to you. I mean, if you just want to write your answer, just write your answer. Go right ahead. No, I'm not grading it. I'll take it every few minutes.
I want to go next.
Ken. Let's get it. No, you're not going next. Okay. Go down the road. Number 15.
Oh, well.
Do you guys even wait around for somebody to maybe help you or anything? I do. No one say anything. All right. So you just trust them after they said say that. Quit cheating, Jesse.
I didn't cheat.
I'm gonna rip you back your book out.
What did you do?
I was just.
Hit the indented button
What did?
On the pen.
No, hit the indented, right now, hit previous, hit it again. There you go. Oh, stop. Is it right? Okay. I was just figuring it was gonna go right back to doing the same thing. Is your mom or dad leaving?
Is that
Joseph and say, gosh, you guys are stupid for believing it. Going to his mom, she punched you with it. Knock you out.
She's probably eating some food. Oh, gosh.
Stop. All right, going through these real quick before we go on to the next one. Give everybody a chance to decide whether they actually believe them for sure before I tell you whether they're right or wrong. So you can help your peers out maybe. Number 12 says segment JK is congruent to segment LM. Then segment LM is congruent to segment JK. What did they do there? Just switched it around. What property is that when you just switch it around? Symmetric. So is that right?
Yeah.
13. 13 says AB equals 14. And CD equals 14. So that's your given information. Then you know AB equals CD. What property did we use there? Substitution. Everybody agree with that? What property might somebody have put down there? Transitive. Is it transitive property? No. What's wrong with it? Why is it not transitive? What has to be true when you're using transitive property about these two things? They have to be the same. It has to go in the correct order. So if they turn this around and put 14 equals CD, then would that have been transitive property? Yeah. All right. So if it doesn't go in the right order, then substitution is the correct answer. Number 14, what I was saying on number 14. If you draw this picture, I can't remember what letters, with the W, X, and Y. You draw this picture, anytime you see that picture, what's the first thing that should pop into your mind? Segment, addition, postulate. Somebody explain segment, addition, postulate to me using this.
WX with XY with the WY.
Segment WX plus segment XY equals the whole thing, which is segment WY. Number 15. How come 15 is transitive property and 13 wasn't? What's in the middle on both of them?
PQ.
PQ's the same on both of them. So it goes in the right order. Number 16 and 17, these are the ones that seem to confuse a lot of people. I have segment EF equals segment TU, and segment GH equals segment VW. They say then EF plus GH equals TU plus VW. What did they do to go from this to this? They took EF and did what to it?
Symmetric.
What'd they do to it?
Substitute.
Look here,
They changed it.
and then look there. What did they do on this side of the equation?
Added a plus.
Added GH to that side. What'd they do over here? Added
VW.
VW. What do we know about GH and VW?
They're equal.
They're equal, they're the same. So we added the same thing to both sides. So what property did we use? Addition, property of equality. All right? This seems to confuse a lot of people, a lot of students, because you're not used to seeing something like this. Now, if I did this, x plus 2 plus 5 equals 7 plus 5, most every one of you would be able to pick out that, hey, you added 5 on both sides. Right? But when you start throwing in all the letters for segments or angles or anything else, it seems to confuse people. So you got to be able to pick that out. Number 17. This is the one that confuses me all the time, as far as why people can't understand it better. My 9-year-old son's pretty good in math, but he can't understand problems. I know they're not the same as your guys' problems. I'm not saying that he's as smart as you guys. That's not. Except for maybe he might be, the person in the back room that spoke up might be right. He might be as smart as you. Looking at this, you start with this. How did you go from here to that? What did they do? They got rid of JK. When you say get rid of something, this is the part he has trouble with because he's doing word problems right now. He can't understand get rid of or take away or those kind of phrases. When you get rid of something, what mathematical operation are you doing? Subtracting. So you're getting rid of JK here, you're getting rid of JK there. Is it all right to do that? Can you just go ahead and get rid of JK on both sides? Yeah. If you get rid of the same thing on both sides, is it still going to stay balanced? Yeah. So subtraction property, don't forget to do this. If you do it to both sides, don't forget to write in subtraction property of equality. Because subtraction property, or subtraction is just something like 5 minus 3. So make sure you're putting that of equality on there. And with those worksheets that I passed back, notice if you looked at those worksheets, I wrote some stuff on there for some of you here and there. Make sure you look at that. Stuff like numbering your steps, putting in of equality, making sure that you're doing stuff right, trying to give you the right idea on those 2-column proofs. All right, on these 2-column proofs, what we're going to do, each person will do one step.
Can I do the first one?
No, I got this.
Notice, I think on this one, they had 6 steps on theirs, right? I have 7. How come?
Because you break it apart.
Because I break apart what?
Given.
The given information. So I want the given information broke apart.
I can do it.
All right, Grant, I shouldn't let you do the easy one. I should make you do a harder one.
Well, I'm taking my book with me.
When you come up, the first 2 people, as they do the given information, I want you to also mark it on the diagram what that given information tells you. So I'll make yours a little harder, Grant. Mark it on the diagram what that given information tells you. Go ahead.
You want the entire given on number 1?
No.
We just said that.
What's this over here, just?
What did you forget before he goes away?
Nope, nope.
What he had up there will come later on in the proof, right? Now he marked the segment AD and segment CE with 1 tick marks. Is that the way you should do it? Yeah.
Oh. Good call, I forgot about that.
He was just making fun of Grant.
No, I wasn't.
I was helping somebody else.
I can do this.
Does everybody understand it up till there? Now let's think it through before Miss Nugent goes up there. Anytime you see a diagram, looks like this right here, what should you think of? We just said it on the last slide. Segment addition postulate. So somewhere we're going to say this segment plus this segment equals the whole thing. This segment plus this segment equals that whole thing. Well, if this has got 1 mark, that's got 2. This has got 1, that's got 2. When we add each of those together, what should happen? They should be equal to each other. The lengths should be equal. That's what we're trying to prove, right? We're trying to prove that segment AB is equal to or congruent to segment CB. All right. Go right ahead. Sorry, I made you wait longer.
Oh, that's fine.
I know you were in a big hurry to get up there and keep going. Don't even throw something you've done. Should this step be a hard one when we get to the test next week? You change from geometry to algebra, what do you always know the rule is? Definition of congruent segments, except after today, because we're going to deal with angles today, guess what that rule or that reason is going to be? Definition of congruent angle. Next one, next step, number 4. Who are we on now, Janet?
No.
Oh, Jonathan. Jonathan, how are you hiding your big behind? Great, I missed you. So you're just gonna take a 0?
I wasn't here on that.
That'd be real helpful.
Making like a little grade.
I don't believe I did.
Yeah, you get discounts your home instead of me walking around checking off homework.
Well, I get
Addition, postulate.
So you get yours right.
Yes.
So then you check.
Read that, right?
I'll give you a 0 for cheating.
That part of the red one.
I can't read that.
That matters. It matters who's you cheated on.
Right there.
Cause he did.
No, it's not.
It says AD equals CE, DB equals EB.
I can't read that.
AD equals CE,
Alright.
DB equals EB.
You need one person saying that at a time.
You want me to just give you the answer?
Okay, look at number 1 and 2. All it is, this and algebra.
AD. There ain't no P anywhere in this picture. They gave you part of it. Did you not use the book?
Yeah, it's substitution, right? Right? Subtraction. Transaction.
Segment addition.
Segment addition, dude.
Segment addition.
You don't even need to know what the last step said then.
Segment addition.
Oh, no, hold on, we're on the wrong one. So you guys, because we stretched it out, right? We stretched it out, so he's on number 3. So they gave him the statement, and he's got to come up with the reason. So mark that out. Make sure you don't forget, we're a step lower than what the book actually is, right? Because we separated. No, the book's,
Alright, so that's what I put for 3. The reason. I got 5. For C?
yeah, you're on step C in the book if you're looking at the book. So they tell you the statement, so you can just write that down.
It's already written down, right there.
No, it's
Now
not.
we're on number.
What?
Back and forth.
Where I have, where I have, where?
So isn't it like AE
Oh,
plus
alright.
D?
Jonathan, a C looks like this.
This.
Actually, it's that.
So AE equals.
Things were rolling along so well. You guys getting ready to compliment everybody on how good it's going.
Okay, you forgot John.
Just read it out, but.
Now, what did they do to go from what it said in 3 to what it, you just wrote down in 4?
Or not subtraction. Or substitution. Addition.
I'm not gonna tell you.
It's
So-
substitution, addition.
Hopefully somebody else will help you if you're not sure.
Is it addition?
We just did this on the last slide.
Isn't it addition of equality? Property of equality?
Is it addition?
Addition.
Yeah.
Right.
Good job.
And he couldn't read number 3.
Next one. Does everybody realize that how we're lined up now?
Oh, yeah.
Hopefully.
If I can read his handwriting.
Right.
Is he good?
You go again. Put you up there and make you do everybody. Now, as soon as Janet seen that her reason was segment addition postulate, that's where you look over and you say this plus this equals the whole thing, then you do it for the other one also, right? Please remember it's segment addition postulate, not segment addition property. If it's addition property, then that just means you're adding something.
Can't remember what the property's called.
Ask your classmates, they'll tell you.
Substitution.
I don't think there's anybody in any of my classes that can spell substitution.
I spelled it right.
No, I don't think so. I don't think I said it spelled right in the last 2 weeks since we've been on it. Next one. What are you complaining about, Lucas? You got like an easy one.
No, that's what's hard. I can't see how on that. Definition.
That's why he doesn't want to wear his glasses, isn't it? Then he can have an excuse for everything. I can't see. It's not an excuse to not know this one.
Good job. That's right. Good job.
All right, let's go through it and see if we're right. First thing, the given information. Not too difficult. This segment's congruent to this segment. That one's congruent to that segment. Then they told us that this segment is congruent to that segment. Next thing, what they do? They went from geometry form into what? Algebra form. Again, later on this year, we're going to do away with that step. For whatever reason, the book does it in this chapter, but they don't do it in other chapters. So later on, this step will be gone, and this step will be gone. So this would be shortened up quite a bit. We changed it to algebra form. Then look at what they did right here. AD, which is here, and they added what to it? DB, which is over here. Then they said CE, which is there, and they added EB to it. So they just sort of added the same thing to both sides of that equation. All right, just added the same thing to both sides. So if you add the same thing to both sides, what's the property? Addition property of equality. Then we got to this step. Segment addition. This plus this should equal the whole thing. This plus this should equal the whole thing. That's what we have there. Now look at what we have. Do you see AD plus DB anywhere else on the slide here?
Yeah.
Right below it, right? Do you see CE plus EB anywhere else on the slide? Right below it. Well, if that is equal to that, what's that tell us about these two things? They have to be equal. AB has to be equal to CB. Is that right? CB, yeah. And how did we know that? When you take something out and put something equal to it in its place, what's that called? Substitution. And then the last one here, what did he do to go from there to there? Changed it from algebra form back to geometry form. Now ours looks pretty ugly now. It's supposed to be a formal proof because it's supposed to go nice and neat. But this one didn't work out that way. I want to help you out just a little bit on this one before we get started on it. I highly suggest that if you didn't do this one, you might be writing this down on a sheet of paper, or even if you did do it, you might write it down on a sheet of paper somewhere that you can stick in your notes. Hint, hint. Shane doesn't take hints well, does it?
No, I know what it is.
Put my segment symbols in here that I couldn't figure out how to put them in on the computer. If it's written in this form, if all this information, then that information. The if part here is the what? The given. So I'm going to just transfer this down to here. So if we know segment YZ is congruent to WZ, and we know that segment YZ is congruent to segment AB. The then is what part? That's what we're trying to prove. Segment XY is congruent to segment AB. Now looking at this, we got our statements and reasons there. Looking at our picture over here. Are we going to use segment addition postulate on this one? It's the wrong picture, isn't it? Doesn't look right. Remember, to be segment addition postulate, it'd be something where you have a segment then some other point in between those two segments. So if we're not going to use segment addition postulate, we need to figure out what we are going to use. Let's look at this right here. Anybody tell me what property you can get from that? Somebody read it out loud.
Segment, I can read, I can't see it.
Segment YZ is congruent to segment WZ. WZ is congruent to, segment WZ is congruent to segment AB.
Anybody hear anything as you read that would lead you to a certain property?
WZ is congruent to AB and YZ.
Transit.
Exactly. So what property are we going to use somewhere through this proof? transitive property, and I'm gonna write that down over here. This is what I'm talking about when you're thinking something through before you actually start doing it. You think it through and you look at it and you say, I'm gonna use transitive property. I write it down over here as a little note to remind myself. Now, as we go through this, somewhere in here, we're gonna use transitive property. That's gonna lead us to what we're doing. All right, who was next? Oh, no, we can't have Sarah doing one of the easy ones. I should probably just let Tristan do both the given information, shouldn't I?
Or you shouldn't.
Right, Tristan, don't listen to them.
What does it say? Yeah, why is he? What's that one? Why is he? WZ. My friend.
I wrote it wrong, didn't I?
Yeah, did you?
Somebody tell me.
What did you write? W.
Go ahead, finish, because I gotta fix my mess up. I don't even know, where did I get YZ from?
Yeah, you was right. I just switched it.
There's a Y and Z.
There's no Y and Z.
Yeah, it is. There's the letters Y.
Oh, there's letters there, but I shouldn't have messed up that bad.
X, Y.
Yeah, it's actually not.
There's a lot.
Where you going?
Oh.
It's X, Y.
Did you know it is?
Teachers these days.
Being around Jonathan too much, you messing up my letters.
Messing up your brain cell.
Oh! Tristan, go back up here. Tristan's got a mark in his picture, or in the picture, what that told him. So give him the pen, Sarah. Look, he messed up just so you have to stand up there longer. That's what he did. Yep. He likes torturing you.
So, that is didn't mean to put that there.
That's all right. Go.
That's congruent and
Okay, good one. Take marks. Take it slow.
You know, I probably had the numbers up there and I didn't click them. I don't know, like 6, I think, or something. Hold on, Sarah. How can you just mark yours with one tick mark? That's what Tristan did.
Sarah, you're right. You don't have to.
How can you do that?
Because they're all congruent.
Oh, okay. I was confused. So does everybody see what happened there?
Mark well.
Tristan marked his with one tick mark, and then she was gonna have to mark WZ again. Well, it already had a tick mark on it, so whatever it's congruent to should also have what on it? One tick mark. So what's that tell us about all three of them? They're all three congruent. This problem, when we do this problem on the final exam, which it may very well something like this be on there. When we do this problem on the final exam, this problem will have 3 steps. That's it. The next step would be it. Because the next step would be right to using the transitive property. Now, Jaylyn,
I can't put that.
no. Jaylyn can't do that because she needs to change it into what?
Why do we have to, I thought that was already for if you were adding and subtracting. It's not.
Well, yeah, but they want it done all the time.
Wait, so what are you writing?
I'm doing the definition of congruence.
I do.
I don't know, you want to skip it?
I was gonna skip it, but.
But then that means Casey doesn't have anything to do.
Well, there's more problems. We have like 40 through 45.
All right, go ahead, we'll skip it. You're sort of right, it's supposed to only be when you're doing addition, subtraction.
So it's not wrong.
Is this problem in the back of the book?
Yeah. Are you ready?
Jesse, you like the back of the book, look in the back of the book, see if this one's in there. Yeah, it is.
1 through 10.
No, they're all.
Yeah.
Let's see how the book did this one. You know, I don't much trust the book on this page. 4? Sure, 4? Could have been 4. Oh, yeah, because they would have put the given all as 1, wouldn't it?
What? I always write everything out.
Alright, so watch. On the test, we probably should have worked this out because I told you to write it down, and then on the test, if I put it on the test, and especially if it's a problem where they want you to fill in the blanks, what other step's gonna have to go in here? Where you change it from geometry to algebra, definition of congruent segments. And then what other step's gonna have to go in at the end? You're gonna have to do what? Change it back, okay? And I bet that's what the back of the book did, wasn't it?
I don't know.
Thought you would look it up
X,
for me.
Y,
Yeah.
is congruent, A, B,
How many steps does it have in the back of the book? 4?
Yeah.
So it's got, this is one step, then it's got changing it, that's the second step. Then it's got that these two are equal, third step by the transitive property. Then changing it back is the fourth step.
That's pretty good. That's actual homework. But then I thought about it, I was like, we don't really need to do that.
And to me, you're right. Is there any reason to change this? Are we adding, subtracting, are we doing any kind of operations to these? No, so you shouldn't really have to change it. That's good enough. I didn't mean to do that. Janet, you get lucky. All you got to do is answer, or I'm sorry, not Janet. Casey, you get lucky. All you got to do is answer me a question. Oh, no, don't do it to me. A is a midpoint. What's that tell me? If A is a midpoint of ZX. Look it up. Look up midpoint. Tell me the definition.
It's halfway to ZX.
So what's that tell you?
Where?
I'm gonna throw you out in the hallway.
Segment.
That's true, this is a segment, but what's it, if that's a midpoint, what's that tell me? Everybody else should be listening to this because guaranteed when we take a vocabulary test next week, right after our chapter 2 test, guess one of the terms on there? Midpoint's on there. Look up midpoint, just look it up real quick in the glossary.
It's a pyramid. It can be a pyramid if you look at it. Kind of like a 3D way. We're looking at a pyramid. You need to.
Splits A. A is a point. How can you split a point into 2 segments? That's like splitting an atom into 2 elephants.
Halfway with.
Okay. Got understand it.
Huh?
Understand it.
You could turn around there and help her.
Oh, she's so far away. Oh, wow, that's too far. It's the line that splits segments.
So listen carefully. Make sure everybody knows this. A lot of you didn't seem to know it. A is a midpoint. It splits the segment into 2 congruent segments. So it's splitting this segment into 2 congruent segments. So you're not off the hook yet, Casey. 'cause I think they helped you too much. So now tell me what that tells us about this segment. Tell me what I can mark here. What's that tell me? If this is a midpoint, what do I know? What can I come up with? What can I conclude?
You said they are.
But she's got to tell me what are. So if you're splitting this, if A is splitting this into two congruent segments, what's the same? Name them for me and tell me. Z, it's got to be a segment. Name a segment for me.
NZX.
Segment ZA, segment, not A and X are the same, segment AX. Segment ZA has to be equal to segment AX. You're not done yet because I think they're still helping you too much. A is the midpoint of segment WY. Shh, nobody help her. She can handle this herself. Tell me that same information for that, if A is the midpoint of WY.
Segment WA, and then Y is
Segment Y. We know that they're congruent to each other. All right? Now, they also told us that this whole segment is congruent to that whole segment. So did I mark it correctly? If I put 1 here, 1 here, 2 here, and 2 here, is that marked correctly? What do we know about all of them? They're all going to end up the same. What property is going to tell us that? Substitution. Somewhere through there, you're probably going to use substitution. Also, since you had a segment that looked like this, somewhere through there, you're probably going to use what? Segment addition, possibly.
Too many steps on this one.
All right, just going over this real quick. These two angles, give me a name for them. What kind of angles are they to each other? Complementary, because they add up to 90. Tell me the equation. 2x plus x equals 90. What kind of angles are these two to each other? Complementary. Tell me the equation.
2x plus 4x.
2x plus 4x equals 90. What kind of angles are these two to each other? Complementary. Tell me the equation. 3x plus 2 plus x equals 90. This was like 40 through 45, the review. Just going back over it because we're going to go back into that next chapter. What do you know about these two angles? Supplementary. Now, not only are they supplementary, but give me another name for them because we're going to use them in these theorems and stuff. They're also a linear pair. They're a linear pair. So they're both those. Tell me an equation for this one. 3x equals 180. Or 3x plus x, sorry, equals 180. What kind of angles are these top two to each other? Supplementary, these two? Supplementary. All right, go ahead and start copying this down. We only got like 20-some minutes, so we're going to be moving quickly. These are your notes for today. You can title this angle proofs if you want to help you out.
Would they be under caution?
No, this is in your notes. Angle proofs. And Jonathan brings up a good point because I had this argument with somebody yesterday. We're actually going to go over the postulates and theorems, but these are your notes. I could make you just write down the postulates and theorems in the postulates and theorems section of your binder, and then say, well, you should know them, you wrote them down, right? And I shouldn't even have to explain them. Can we do it that way? Probably not. All right? So what we'll do, each time we have a list of postulates and theorems, you'll write them down in your postulates and theorems section, and then we will cover them, my explanation of them to you, so that you can have some idea. Maybe I can better explain them than what the book said.
We do all that?
No, we're skipping that today. I gotta get through it. All right, postulate 2.10. We're going to move extremely quickly, so make sure you follow along and write quickly. This one is called the protractor postulate. Last time we had the ruler postulate. Protractor postulate does something like this. It says you have an angle. You line that angle up on the protractor with the point in the middle at the bottom of the protractor and one of the sides of the angle out the bottom of the protractor along with the black line that's on the protractor normally. And the other side of the angle goes up through the top of the protractor, something like that, and it crosses a number. And that number that it crosses tells you what? The degree, the measure of the angle. So what's this whole postulate telling you? How to measure an angle, or how to use a protractor, either one. Same as the one before told us how to use a ruler. Two 211 is called the angle addition postulate. You ever heard anything like that before?
Oh, yeah.
Where?
I was kidding.
In this
What was it? What an angle addition postulate? Segment addition postulate.
Oh, we just addition possible.
Segment addition postulate. So, with your knowledge of segment addition postulate, anybody tell me what equation could I set up from this using the angle addition postulate?
QR plus RS equals.
Lord Q.
No. I was thinking it's never putting them on.
Angles.
Oh.
How many letters to name an angle? 3. So the measure of angle, what?
QRT. Well, no, QRS, because R has to be in the middle. Wait, no, the
Name this angle up top here for me. QRT. So the measure of angle QRT
Plus TRS.
plus the measure of angle
TRS.
TRS, that's the bottom one,
QRS.
equals the measure of angle,
QRS.
the whole thing, which is QRS. If you can read that. That's terrible. I'm going to rewrite it over here. Measure of angle QRT, just going back over it, it says top angle here, plus the measure of angle TRS equals the measure of the whole thing, which is QRS. Hey, something I didn't notice. The big cursor's gone. I bet Mr. Poole came in last night and messed with my computer.
Oh, the one thing.
Because I wondered, because this morning I came back in and now all my icons on my screen are huge again, like I'm some 80-year-old man that can't see anything. I thought, why did that change?
You should see a little better than that, dude.
Next one. Theorem 2.3. It's called the supplement theorem. And I'm going to use just some abbreviations here. The supplement theorem says if two angles form a linear pair, then they are supplementary. So I'm just going to write it this way. If you have a linear pair, Remember that arrow means implies or tells you or however you want to say it. If you have a linear pair, then what else do you know you have? Supplementary angles. So if you know that they're a linear pair, then you know that they're supplementary angles. Hopefully you already knew that. We talked about that in chapter 1, right? Theorem 2-4 is called the complement theorem.
Same thing.
It's sort of the same thing except it deals with, alright, so I'm going to draw a picture for this one. If you have two angles together and they make a right angle, then what do you know about those two angles?
That is 90.
So they are, what kind of angles? So they're complementary angles. 2-5. No, don't do that, you stupid thing. Tired of blue. Theorem 2-5 gives you the three properties again. One of them's reflexive. What was the other one? Reflexive, symmetric, transitive. Last time we said that all three of these properties work for algebra and they work for segments. This time, guess what they're saying? They work for angles. Very good. They also work for angles. So now you know that they work for everything that we're going to deal with. Let's give an example of each. Use numbers to name angles. Just make up some angle. Reflexive property. Tell me an example using angles.
Angle 1 equals angle 1.
Angle 1 is congruent to angle 1. Very good. Give me an example of the symmetric property.
Angle 1 is no.
Let's use a different, let's not use the same angle.
If angle 1, or angle 2, if angle,
Angle 1, go ahead.
if angle 1 is equal to angle 2,
Angle 1 is congruent to angle 2.
then
Then
angle 2 is congruent to angle 1.
angle 2 is congruent to
Angle
angle 1. Transitive property. Transitive property is a little tougher. It's got to have three parts to it. What's that going to say?
If angle 1, hold on, angle 1 is congruent to angle 2,
And
angle 2 is congruent to angle 3,
then we can decide what?
angle 1 is congruent to angle 3.
Give you a second to make sure you get that down. Before I throw something at Grant, I'm going to have to move him back to his proper seat too, aren't I, Jesse? Where was it at? It was right here, wasn't it?
No, Jesse's up there. Jesse's in Lucas.
It's up there where Lucas is at?
Yeah, Jesse's in.
No, you sat right here.
No, you didn't. No, Jesse is in my
Actually, it
seat.
might have been where it came.
Now, this will be your new seat when I move you. Right?
And then that'll be my new seat.
No, that'll be your always seat. So reflexive property, please remember with reflexive property, anything equals itself. Symmetric property just turns the things around. Transitive property, don't forget that you have to have the two things in the middle have to be exactly the same. If it's not, then it's not transitive property, then it would just be substitution. Hurry, because I'm switching it. Theorem 2-6. I'm going to write the abbreviation for Theorem 2-6 up here. Angles supplementary to the same angle are congruent. All that means, if I tell you angle 1 is supplementary to angle 3, and angle 1 is supplementary to angle 2, What's that tell you about angle 2 and angle 3?
They're the same.
They have to be the same. For those two to add up with angle 1 to equal 180, then they have to be the same as each other. Theorem 2-7, same idea. Theorem 2-7, same idea, except it's dealing with complementary. So angles complementary to the same angle are congruent. So if angle A is complementary to angle B, and angle C is complementary to angle B, then what's that tell me about A and C? They have to be the same. They have to be congruent. That's the only way it mathematically can work out. Theorem 2-8.
This is the last one.
No. Theorem 2-8. This is the easiest one though. Might put a big asterisk beside this one. It's the shortest theorem in the book, and it's a theorem that we use the most in the book. Vertical angles are what? Congruent. Looking at this picture right here. Which angles are vertical angles?
1, 3, 2, 4.
1 and 3. So what do we know about angle 1 and angle 3? They're congruent. 2 and 4 are congruent. Theorem 2-9. These last 5 I'm going to run through sort of quickly. Theorem 2-9 says if you have perpendicular lines, everybody know that upside down T means perpendicular, right? Perpendicular lines. If I draw two perpendicular lines, two lines that are perpendicular to each other, what's that tell me about these 4 angles?
They're all congruent.
They're all congruent. They're all 90 degrees. So perpendicular lines means 4 right angles. If you have perpendicular lines, then you're going to have 4 right angles. 210. These last bunch, sort of common sense. You already knew that, right? If you have perpendicular lines, then you have right angles. Hopefully you knew that. 210 says, this is another short one, all right angles are congruent. So if I tell you angle Q is a right angle, angle R is a right angle, what else can you say about them? They're congruent to each other. I'm not sure why they have that as a theorem, because we could make up a theorem, Kenny could make up a theorem saying all 30-degree angles are congruent, and we call it the Kenny theorem, right?
Yeah.
211. Perpendicular lines form congruent adjacent angles. So if you have perpendicular lines, again, I'm going to use the arrow to make it a little shorter. That tells us that the angles are congruent and adjacent. What's adjacent mean again? Neighbors. They're hooked together right next to each other. So that's saying if these two lines are perpendicular, then I know that these two angles are congruent to each other and they're adjacent to each other. Sort of another common sense thing. Next one. If you have angles and they're supplementary and congruent to each other. So I tell you angle 5 and angle 6 are supplementary to each other and they're congruent. What can you tell me about angle 5 and angle 6? We know that they're supplementary and they're congruent. Each one has to be what kind of angle?
Right angle.
Then they're right angles. That's the only thing that'll add up to 180 and be congruent to each other. And 213. If two congruent angles form a linear pair, no. So we have 1 and 2 here that form a linear pair. If I tell you angle 1 is congruent to angle 2, then what do you know about them? They both have to be 90 degrees. Both are right angles. Both have to be right angles. It's the only way it works out. Again, these last 5, we don't use them a whole lot. This is just definition of perpendicular lines. We know that they form right angles. This one here we will use later on in the year when we start talking about triangles. But hopefully you realize that all right angles are equal to each other, congruent to each other. These, you just got to sort of use. We've been using them all year long when we talked about supplementary and stuff. If I give you this and I tell you this is x and this is x, well then you know x plus x has to equal 180 and all that stuff. Alright, we're not going to do this practice. Normally we would, but since we don't have a whole lot of time. The homework's on page 112. If for whatever reason you didn't get back both quizzes, you might talk to me to make sure that you took both those quizzes. I think everybody in here did. Whether it's like you did.